Okay, guys. Okay, so we're gonna go ahead and do now a mixture of both. Okay, so really quick. Um, this is really just a refresher of what we've done all week, really. But now you're gonna see both types of questions. Okay, in your assignment. So now in here again, let's go ahead and refresh your mind. One mole will always equal to 6.02 and sorry, it was cut off, 23rd times 10 to the 23rd power. Now, this could be particles, atoms, sometimes they call it molecules, formula units, but this number is Avogadro's number. We know that one mole always will have this huge number. Okay, so what does this represent as per conversions? Well, sometimes we want to know when we do a chemical reaction how much is going to come out. So we need to know how many particles. So since we cannot see it, we need this conversion to calculate how much will yield from whatever experiment we're doing or whatever maybe we're doing wine or whatever we're cooking. Okay, so basically in here, this when we're this signifies it's really equal to two different conversions. It's either 1 mole divided by 6.02 times 10 to the 23rd particles, or 6.02 times 10 to the 23rd particles divided by 1. Now, if like this one, if you divide it, it will equal to 6.02. But this one, 1 over 6.02 times 10 to the 23rd, it will give you a different number. So while you are doing this kind of conversions, you have to kind of decide, oh, is it this one or this one? Okay, so so through this process, you need to decide on that. But in order to decide that, before you even do this, you of course, I showed you the strategy of gum. Okay, you gotta first organize yourself. Do this strategy to help you know which one you're gonna apply. Okay, so you always start with your G. Your G is your given number. The given number, I'm going to go ahead and always highlight it in green because it's so important, the given, because that's how you start. That's the number you start. So like on number one, let's go ahead and look at the word problem. How many moles of magnesium is 3.01 times 10 to the 22nd atoms of magnesium? So in here, if we look at, of course, this is your given because that's the number they give you. Okay, so that's your given again, and that's a number you always start. So it will be 3.01 times 10 to the 22nd atoms. Okay, now I do suggest that you practice with G and the U and the MM. Now I know in the beginning it's like a lot of writing, but it's so worth it because it sticks to your head, and before you know it, you do it without even thinking those conversions, without even doing this. Okay, but first practice with doing this. Okay, now that's my suggestion. Okay, U means unknown. So what are they asking for? How many moles? So that's your unknown. So moles will be, we don't know. We're trying to solve for that. But we need the units. We really need the units for the given and for the unknown so we can know which one to use. So super important, the given and the unknown. Now molar mass is only within the story they give you grams or they talk about mass, which is the same thing, but this is a unit and this is the significance, the meaning of what it is. Okay, so since we don't have to deal with grams or mass in here, we are just we don't need part of this conversion. Okay, so now let's go ahead and start with our conversion. We start with a T since we're just converting it once. And keep in mind that we're going to be converting up to 5 of them, at least in chemistry. And in my experience in college for chemistry, I mean, we've done up to 10, or I mean, they can go on for a while. However, I mean, once you know the setup, it's actually not that bad. It's really easy. Okay, but you gotta learn the pattern. Learn the pattern. That's what my suggestion. That's how I experience how students actually get it more than versus like the more complex, just other different ways. Okay, at least that's my experience. Anyways, okay, so let's start with your given. It will be 3.01 times 10 to the 22nd. And of course, that's atoms. Again, you always start with your given. Okay, and I'm going to put this in orange again because that is so important, because diagonally, this is atoms, and diagonally, you will put atoms the same on the bottom. Super important, the units. It's not really the numbers. First, look at the units. That is where it will tell you the pattern. That's how you can tell how your answers are going to go. Okay, so so that's atom and atom. Okay, and then your unknown. Your unknown is the unit of moles. So that is the last one always, and on the top always. Okay, so moles. So in here, of course, now you're ready to decide which one you're gonna pick. Okay, so keep in mind that atoms, particles, and molecules are in formula. It's the same wording. Sometimes I even hear ions, and so on. As long as it has this number, then it's Avogadro's number. Okay. So anyway, so atom, if you since you see atom here, that means we're dealing with this one. That means it's Avogadro's number. It will be 6.02 times 10 to the 23rd. And then, of course, where do we put the one mole? Remember, these are the only numbers we're really putting. And very important, the numbers, because we're calculating, we're trying to convert from atoms and how many moles it has in there. Okay, so in here, it will be 1 mole. Okay, so from here, you see how it's atom and atom? This cancels. Those two cancel. Why? Because it's going from atom, and when you calculate this and you put in the calculator, it should give you the unknown number right here as your answer for moles. Okay, so in here, let me go back to this because some of you probably, I don't know if you know this bottom part. This bottom part, you just ignore it. There's nothing there, or you could just put a 1. It doesn't matter. There's really nothing there. Okay, so let's go ahead and calculate it. So it will be, and I will show you on this one because since I'm not gonna have time to do the other ones. So it's 3.01, and this is an exponent of 22. So how do you get your exponent? You go to second, and you see how it says EE on blue? You click on that, and you should have an E, and it should be 22, and then you put a parenthesis, and then 1 is first, divided. Why? Because 1 is on the first one because it's on the top. Divided, and then Avogadro's number, 6.02. Again, the exponents with the EE, second EE, and then it will be an exponent of 23. You don't have to put the times 10. You close it with a parenthesis. Think of it like that. You see that? How it kind of matches that? Okay, so now you enter it and you get 0.05 moles. Usually moles is a small number. Okay, now let's go ahead and do the next ones. Now the next one, unfortunately, I'm not going to have time to do that calculation, show you in the calculator, but I will surely show you later on. Okay, so how many molecules are there in 4.0 moles of glucose? Okay, so glucose is this big molecule, okay? So maybe we might not even have to do molar mass, so just because it has it there. So now let's start with the given. The given is 4.0 moles, okay? So that I always put it in orange, 4.0 moles. Okay, so now your unknown is molecules. This is your unknown, your U. So that will be molecules. Now we're trying to solve for this, but we need the units. That's so important. We need the units to help us decide which one, how we're going to convert. Okay? Now, do we need molar mass? No, because there is no grams, which is mass. Okay, so we don't need it. Okay, So now let's start. Let's go ahead and do our T. Okay, we don't do anything here. And how do we start? Which is first? Your first is always your given, which is 4.00 moles. Okay, and then I'm gonna highlight it in orange. Keep in mind that that's moles. That needs to be moles as well. Okay, and then your last one here, your last unit that you need to write, we don't write the numbers yet. We do that towards the end. The last unit will be molecules. So that will be molecules. Okay, so pretty much we're ready to decide if it's this one or this one. So since molecules is on the top, you see how molecules is here on the top? Remember that particles, atoms, molecules, you see that? So this one, this Avogadro's number goes on the top. So they will be 6.02 times 10 to the 23rd. And then the moles will be the 1, of course. Okay, and then you put equals. Okay, so we're ready to calculate. That will be a total. Now, of course, oh, I forgot to cancel these. That's very important because you're going for moles, and now you're trying to. Oh, you have this many moles. You know this, and then you're like, okay, well, I want to know how many atoms. Since we can't see it, you know, it's going to be a huge number, right? Because it's molecules. So this the answer, you put in the calculator, it will be 2.41 times 10 to the 24th molecules. And that is your answer. Okay, so now let's do molar mass. Okay, the molar mass, now for molar mass, 1 mole equals molar mass. Okay, molar mass means grams, but the molar mass can be in an element or compound. Now, we don't know the number. Like Avogadro's number, we knew it. We know that it's this one. So what is this? Well, it varies. It depends on the element or compound. We need to calculate that according to what it shows in the periodic table, and I will show that in a little bit. I know we practiced that, I believe, on Tuesday or Wednesday. Okay. Now, just keep in mind that 1 mole, when it says 1 mole equals molar mass, that means it's the same thing represented through conversions, either 1 mole over molar mass or molar mass over 1 mole. Okay, so let's start with the first word problem. Okay, so again, how many moles? So moles, right off the bat, they're asking for it, so that's my unknown. That is my U. So it will be moles right here, your U. Okay, R in, and then this they give it to you. So this is your given, 15 grams. Okay, this is how much you have in your hand. You're like, oh, I have 15 grams. I need to know, how many moles I have in here because I need to do this much. Okay, so anyways, so if you see grams or any type of mass in there, that means you need to get the molar mass of an element or compound. Since we're dealing here with lithium, that's just an element, so that's easy. We don't even have to do any multiplying or adding for molar mass. So for molar mass, all we have to do is look for the numbers. So lithium is right here. So the mass, which is the bottom, is 6.941. So I'll just go ahead and put 6.941 grams. And now this is per mole. You see how molar mass is grams per 1 mole? You see that? How right away it starts connecting to the conversions. Okay, so anyways, okay, so let's go ahead and get started. We're gonna go ahead and do our T since we're just doing one conversion. So in here, it will be now again given. We always start first, so it's 15 grams. Okay, and now keep in mind that I like to color my given. So if this is grams, that means the bottom is grams. Remember, you do not put any number in front of it yet. Okay, not yet. Figure out the units. Trust me on this one because later on when it gets a little, worry first about the units. Okay, so this will be grams. So if this is grams, okay, that means that has to do with the molar mass. Now keep in mind, look at my unknown. That gives you a big clue. That means it's moles on the top, right? It's the last one on the top. Okay? So that means it's this one right here. So it would be 1 mole, and then you get the molar mass, which the molar mass of lithium, again, molar mass of lithium. This is it. You always get it in a periodic table. Always. Okay? So here is how much lithium, because every element has a weight. It weighs. Okay? So this was 6.941. Okay? So now we already have our numbers. Okay? These cancel out. Remember, there's nothing here on the bottom. Okay? And we already converted from grams to moles. So this is an easy one in the calculator. So it would be 15. Now keep in mind, like if you're confused about this, you just put parentheses here. So it would be 15 and then put a parenthesis. And then 1 goes first because that's on the top, divided by 6.941. Close it up with a parenthesis, and then that should give you 2.16. 2.16, and of course it's moles, and that's what we're trying to solve, moles. And that is my answer. And of course, lithium, we're trying to find lithium. How much of that element is there? Okay, let's look at now compounds. This is an element, the molar mass of an element. So I like to use both so you guys could see the difference. Okay, so now how many grams are in 4.5 moles? So again, this right here is my given. Okay, and so my given is 4.5 moles. And my unknown, this is my unknown, my U, and this is my given, my G. Okay, so here it will be grams. We don't know the grams yet until the end. Okay, so now, since we're dealing with grams here, there is grams in the story, so that means we have to do the molar mass of this compound, which is sodium fluoride. Okay, we want to know the molar mass. So all we have to do is break it by atoms. So it's Na and then fluorine. For every capital letter, there is an atom. Okay, so here is only 1 sodium, so it's 1. You have to count how many atoms there is. Okay, and then fluorine, there's only 1. Okay, and then you multiply because believe it or not, each atom has this mass. And that's when we do experiment, that's what really comes out. Okay, so in here, so sodium, it will be 22.99. 22.99. And then fluorine will be 18.998. So of course you multiply, and that's easy because each one is 1. So it will be the same thing. So you add them up, so it should give you 22.99 plus 18.998. That should give you 41.988. And then this is grams per mole. You see how grams per mole kind of related to grams per mole. Okay, so, but we need to decide which one, but we need to do the setup first, okay? So remember that your given is always first, unknown is last, okay? And I want to color, remember, I got to color it. Okay, so in here, let's go ahead and do the T. Okay, this one, there's nothing in there. Okay, we've given is always first, so it's 4.5 moles. Okay, so 4.5 moles. So that means if this is moles, that has to be moles. So right off the bat, you should know that it's 1, right? Okay, anyways, let's go ahead. It's grams, so this is grams. So that means if it's grams, that means it's a molar mass. So that would be 41.988 and per mole, right? Per mole, you see how it's division. Okay, so anyways, so let's put the parenthesis. And if you put it in the calculator, that should give you Let me see here. I think I have the answer here, so I don't have to calculate it. It should give you 188.96 grams of sodium fluoride. So that's how much you get out of that. Okay? Okay, you guys, it's a wrap, you guys. I hope it was quick. Sorry, it's like, I tried to do it as quick as possible. Okay, I'll see you guys later. Have a great weekend.